So here in this question, we have to find the derivative of a raised to the power of sine inverse of x whole squared. So what we're going to do is we'll use the result that the derivative of the exponential function a raised to the power of x is given by a raised to the power of x times the natural log of a. So let's use this. So this is going to give us a raised to the power sine inverse of x whole squared. So what we have done, we have assumed that sine inverse of x whole squared is equivalent to x. So that will be times natural log of a multiplied, since it's not, so we have to multiply it to the derivative of sine inverse of x whole squared. Now, if we assume that sine inverse of x is x, so we can apply the power rule. So the power rule is given by the derivative of x raised to the power of n. So that's equals to n times x raised to the power of n minus of 1. So we have a raised to the power of sine inverse x whole squared multiplied to natural log of a times 2 times sine inverse x raised to the power of 2 minus 1. So that's the power rule. But we have assumed the sine inverse of x is equals to x. So that means we need to multiply it to the derivative of sine inverse of x. Now we know that the derivative of the sine inverse is derivative of sine inverse of x is given by 1 over under root 1 minus x squared. So we finally get a raised to the power sine inverse of x whole squared multiplied to natural log of a times 2 times sine inverse of x, 2 minus 1 will be 1, times 1 over under root 1 minus x squared. So that gives us 2 log of a times sine inverse of x multiplied to a raised to the power of sine inverse of x whole squared divided by under root 1 minus x squared. So this is the derivative of the given function.